This conference will now be recorded.
All right, we started with predictive analytics, right? And we started with classification predictive scenario in the last session. So I think we already built this classification predictive model. So we trained the predictive model. So I already shown you, right, how different factors influencing your marketing campaign and the term deposits, right? I already went through this in the last session. So then you got something like confusion matrix, guys. Confusion matrix is nothing but it gives you the accuracy of your predictive model. Here you see classification rate is nothing but accuracy. See, whether you understand confusion matrix or not, it's fine. Okay, so what confusion matrix contains? Predicted yes and actual yes. So generally, guys, so this 4.87 we call it as true positive. True positive means prediction is positive, actual is also positive. So this 6.43 is true negative. Sorry, false positive. I'm sorry, false positive. Prediction is positive, but actually is negative, so it's a false positive. Then this 6.43% here is false negative. Prediction is negative, but actually is yes, so it's false negative. And this 82% is true negative. Prediction is negative and actually is also negative. Okay, so we call them as true positive, true negative, false positive, and false negative. Okay, so classification rate is nothing but true positive plus true negative, 82.82%, 27% plus 4.87%. Okay, that's nothing but 87.14%. Your classification rate is this. Okay, I think I written this somewhere. So here you see. So your accuracy or classification rate is true positive by true negative by overall. That is this. 400 plus 450 here by, okay, like this you see. Sensitivity is true positive by true positive plus false negative. Sensitivity is 43% here, means this is 4.87% by 4.87% plus 6.43%. Means how much predictions are accurate, how much positive predictions. So this one, this is sensitivity, 4.87 by 4.87 plus 6.43%. Specificity is 82.27 by 82.27 plus 6.643. We got 92% specificity. So means negative predictions are good, but there is some accuracy difference in positive predictions. That's the reason our predictive power is at 60%. So you see precision also, guys. You have the formulas, guys. You can make you just see these formulas and you'll understand. Positive precision, F1 square, etc., etc. Okay. Fallout is 7.25%, guys. See, in a predictive model, you should have high classification rate, high sensitivity, high specificity, high precision, and low fallout. In my case, I have very good classification rate, very good specificity, very good fallout, but sensitivity and precision are on lower side. Sensitivity and precision are based on positive predictions, so they are on lower side. Negative predictions are good, and overall classification rate is also good. Okay, so this confusion matrix gives you how accurate or how sophisticated your model is. So I generally, in a classification predictive scenario, your classification rate should be between 75 to 95%. I repeat, in classification predictive models, this classification rate should be between 75 to 95%. Ideally, it should be between 85 to 95. Okay. So in my case, it is 87%. This is in the ideal range. Okay. And then you got profit simulation. This tab is also not. See, guys, generally we don't. If you we generally go through the overview tab and influencer contributions. That's it. Confusion matrix, profit simulations. These things, they're just to give you more understanding on the data, not data, sorry, on the predictive model. So profit simulation is nothing but, okay, how much you are saving by using machine learning. Okay, so suppose, guys, here you can give the cost. Okay, so cost for predicted positive, I did give it as $1. Okay, and profit per actual positive, I give it as $100. So generally what happens is, to go and reach out to one customer, we're charging around $1. If we identify one customer who might go with a deposit, and we are making a profit of around $100. So then you see here, the total profit using predicted contacts is 38,000. Means if you use predictive analytics, we make profit of 38,000. If you don't use predictive analytics, you'll make a profit of 9,000. So the total gain using predictive analytics is 28,000. This is nothing but 38,000 minus 9,200. Okay, and you have a gain of around 309%. This is what you see. So if I say maximize profit, you see. No, sorry. 20%. So if you speak to 20% of the population, you have 1600 contacts. Okay. So using predictive analytics, you make this much. So this is just to give you an understanding how much profit you make using this predictive model. That's it, nothing else. Generally, we don't visit these tabs, guys, very honestly. Performance curves also we don't visit. So this is RSC chart, we'll plot this between perfect model and random sampling. Then you see lift in the sense, so is how many times we predict the customers who might do a deposit with us. Means, for suppose if we speak to 10% of the population, okay, if you identify one customer without in random sampling without machine learning, if you have a perfect model, you would have identified around 7.24 customers. With random sampling, one customer, with perfect model, 7.24 customers. With our model, 5.12 customers. Okay, that is what we see. So how many times more customers will identify, okay, using the predictive model. That is what it shows you. Okay, so these are some curves, remaining curves. You can ignore these things. Performance curves we don't visit, guys. Profit simulation also we don't visit. Even we don't visit confusion matrix also. Just give you some understanding. I just visited this. So what we did was we created a proper predictive model on top of your data, historical data. We used the historical data and created a predictive model. Okay. There is one point to be remembered. We don't build a predictive model on a day-to-day basis. You don't load the data into predictive scenarios on a day-to-day basis. Okay. So one point I forgot to mention. So we don't really create predictive scenarios on day-to-day basis, or we don't. If for suppose here I have the data, okay, bank's marketing campaign data. You don't keep on adding new data to this, okay? So that never happens in predictive scenarios. You'll have historical data, okay? You loaded historical data, you got the predictive outcome, and we applied the predictive outcome on the current data, and we got some predictive results. Fine. So next month also they got some new customers. They want to apply predictive model on those customers also. So every 1 month or every 2 months, we'll keep on applying. We don't train the predictive model frequently. Okay, we keep on applying multiple times. Same, once the predictive model is created, it will be applied on the data sets multiple times. I'm going to show you that how we apply it on the data sets. Okay, and also, uh, so maybe guys down the line, after 2 years, so the bank thinks the dynamics have changed very heavily, and this predictive model is not giving them the results. Then what we do, we again recreate the historical data set. Okay, so means we did the predictive model training this year. So after 1 year, the organization thinks there are a lot of factors influencing the deposit now. So in that case, what we do, we again create a new historical data set and retrain the model. Okay, with all the new data and retrain. So maybe we'll retrain the model once in a year or once in 2 years with some new data. That's it. Okay, now so we're done with step 2. Here you see. So we created predicted data sets. First step is done. Second step is done. We created a predictive model on the historical data set. Now let's apply this predictive model and current data set to get the predictive outcome. Okay, so here you have an option. Let's apply your predictive model. This is the option. Apply the predictive model on current data sets. So what model, on what predictive data set I want to apply this? I'd like to apply it on current data set. Okay, on the current data, I would like to apply this predictive model. Guys, it will, once we apply predictive model on current data, it will generate a new data set. It will generate another data set. Here you see, it will be applied on current data set. It won't predict on this data set itself. It will create a new data set altogether. Here you see an option called generated data set. Okay, what name you would like to give to that generated data set? Where you want to save it? I would like to save it in smart predict data sets. So for that generated data set, I give it as predicted data. Okay, and what columns you want in that predicted data? So here you can select what columns you want in predicted data. I would like to have key, age. Is these columns may be an influencer, may not be an influencer. Fine, just fill out what you need. How many campaign calls made? Yes, since last contract, previous campaign, employee variation rate, consumer price index, consumer confidence index, Euribor average rate, job category of employee, marital status, education. Okay, so here I'm selecting term deposit, yes or no, but it won't predict in this column, guys. I'll show you. Select. Okay, so it replicated all the columns. So you got around 19 columns I selected from the current data set. Okay, and then along with these 19 columns, it will also come with some extra columns like from statistics and predictions. You would like to see on what date this predictive model has been applied. You pick the apply date. Means along with 19 columns, this will be added as another column, 20th column.
I also pick assigned bin. What is an assigned bin? I'll cover. Outlier indicator is for regression, so I'm not selecting it. Then I have an option called predicted category. Predicted category, guys. Predicted category gives you an understanding about, okay, here it will predict you whether this customer will make a term deposit or not, and prediction probability also I'll take. Okay, I'll take prediction category and prediction probability. Guys, I see few people joining with different names like Apple, these kind of things. Please try to write your name, because some people using this bridge, others for joining. Please. I dismiss who is Apple. Just try to reconnect with your name. Okay. So guys, along with these 19 columns from the current data set, it also comes with 4 columns, like it also adds. So now this predictive data set will be generated with 23 columns. Okay. Right now, let's say apply. Go to your predictive model. Here you will see it's applying now. It's applied. So now your predicted data set has been created successfully. Key is not a measure. I change it to dimension. Each campaign calls days since last contact. Even assigned bin is not a measure, guys. Even I change this assigned bin also to dimension. Okay, fine. So here you see all your apply data. Key, age, campaign calls, days since last contact, previous campaign calls. Okay. Employee variation rate, consumer confidence index, Euribor average rate, job category of the employee, marital status, education, loan defaults, contact mode, day of week, previous campaign results. So whether this person will make a term deposit or not. So it's not predicting here. So I'll delete this column because I really don't need this. So then here you see predicted category where it will predict whether this person, whether this customer will make a term deposit or not. So prediction categories, no or yes. Here if I go to the dimension details, okay, I see only no's, maybe I'll see yes somewhere. So applied date, so this is the date on which it got applied. Assigned bin, and this is the prediction probability. This is the probability at which, so it's a 0.02 probability you will make a deposit with the bank. Okay, so predicted category gives you a complete picture. So here I just rename this as from predicted category to predicted term deposit. Let's say validate your full data set. So data set has no issues. Let's save it up. So now we have predicted data set ready, guys. We applied the current data on, so we applied predictive model on the current data and this, and they generated so which customers will make deposit with the bank. Okay, so now you need to show, now I need to show this to the end users, guys, to the business users. How you showcase? We show in form of a beautiful dashboard. So let's create a story on predicted data set. Okay, let's go ahead and create a story on predicted data set now. Okay, so now let's go ahead, create a story on predicted data set here. Uh, so I have my predicted data set. I can directly create a story on the data set itself, right? So let's go, I'll create a story here. So I start with some canvas page. I'll go for classic design experience because I need a grid page here. I'm going for classic design experience. Okay, so guys, now let's go create a story. So let me insert a chat here. So I'll choose my model as this data set. So I'll go with predicted data set. Here in the predicted data set, I'll go for bar column chat. I want to see how many customers will deposit or how many not. So let me create a new calculation just to identify the customers. I'll go like aggregation to get the number of customers. where I go count dimensions, count my keys. So we got around 10,000 customers in the applied data set. So here I'll add a deposit for like predicted term deposits. So I go to the file. Let's edit my story preferences. For chats and geomaps, I'll add this. Default color palette is this. For tables, for input controls, apply these topics. Okay. So I got like out of 10,000 customers, 141 customers might come up with yes, and 8859 customers might not deposit here. So here I say this is like predicted term deposit of the based on the customers. Okay. Okay. So you want to see the details also, I can go add a grid page here. Okay. So here I insert a new table into this grid page. Okay. Here in the measures, I would like to see the age of the customer, the number of campaign calls happened on the customer, employee variation rate, consumer price index, Eurobar average rate, prediction probability on the customer. Okay. I would like to see these measures. In the dimensions, I would like to see the customer key. Okay. Then contact mode of the customer, on what day we are contacting the customers, education of the customer, job category of the customer, marital status of the customer has any loan defaults. Okay. Previous campaign outcome on the customer, predicted term deposit of the customer. That's it. On what date this has been applied. I would like to have these dimensions. Here apply date, I'll put it on the top. Key in education of the customer, job category of the customer, marital. First I'll go on job customer details. then contact mode, loan defaults, predicted term deposit. Okay, so here you see all the details of the customers. What's the predicted term deposit? So here I go to prediction probability. So I would like to see the customers who might potentially make a deposit with us. So here I go to prediction probability, and in the sort options, go from highest to lowest. So on the top, you see all the customers who might make deposits with this. Okay. So now you see all the customers who might go with the deposit. Is it the predicted term deposit? Is yes, 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 yes. Okay. Edit delimitation. So guys, I go custom. Uh, 16 columns guys total. And I would like to see only the top 2000 rows guys. Top 2000 customers who might make. Because only 1100 customers has this, right? So I just go 2000 customers and 20. So you see all the customers. So this grid page will give the bank marketing teams an understanding who might uh, respond in a positive way, where the predicted term deposit is yes. So they will focus only on these customers who might respond positively, only on these customer keys. Okay, clear? Makes sense? So that is the agenda of my predictive scenario, right? So here you see guys. So what is the agenda of my predictive? Identify which customers might potentially subscribe for term deposit. So this grid page shows all the customers who might potentially subscribe for term deposits. Right, we achieved that. Okay, and also we also wants to see what are the factors influencing the term deposit subscription. Understand the reasons for term deposit subscription or factors influencing the term deposit subscription. So in the analysis tab, I'll put down all the factors which influence your term deposits. So let me save this story first. Okay, so these many customers will not make a deposit with the bank. So guys, here you also have an assigned bin, right? You want, I'll show the assigned bin how it looks. So here I'll go the measure as customers, dimensional pick, predicted term deposit, and also I'll pick assigned bin. Okay, the customers I don't have decimals, so here I'll go decimal and make 0. So guys, here you clearly see Out of this, like 819 customers has prediction probability as 0, no, and assigned bin is 2. So guys, assigned bin is like a percentile or quartile, how close it is to this value. Okay, how close it is to the value. So generally, for suppose guys, if prediction probability is 0.00001%, so it is prediction no, and the assigned bin is 1 or 2, means it is very close to no. 3, 4, 5, going forward. Here you see there are 796 customers where assigned bin is 9 and prediction is no. Means though the prediction is no, but there might be a chance on these customers. Means they are not so close to no. Here, if in assigned bin 2 guys, prediction probability might be 1% or 2%, but in this 9, the prediction probability might be 15% or 16%. Okay, there's a difference. So assigned bin gives you how close we are with the uh, predicted value. So generally, your bank team, marketing team, so first they will focus on they will target the customers where predicted category is yes, where prediction is yes. Then even if they have some time, so this is not 10 guys, this is actually 1. Okay, so even if they got some marketing budget, they will focus on the customers where prediction category is no, but still assigned bin is 9. Then they go for 8, like that. Okay, this is like a percentile or quartile, how close it is to that value, right? So you see that how many customers will be predicted. So in this case, now what I do is, now let me show how different factors influence your outcome. Okay, predicted outcome. So guys, here you see the major influencer is Euribor average rate. Okay, so I would like to see how Euribor average rate influencing my number prediction category. Here, if I just go in influencer contributions, this. So what is my Euribor average rate? What is the range of my Euribor average rate? Start from 0. So I see from 0 to 1, 0 to 2 mostly, then 4 to 5. Okay, I'll put something like 0 to 2, 2 to 4, and greater than 4, something, 3 categories. Okay, here I'll go insert a new chart. Okay, so here I'll go with customers in the dimension. Okay, so I'll create a calculated and create a not dimension, but control, I'm sorry. I'll create a calculated dimension where I go for measure based dimension. I'm converting Euribor is like measure, right? So if it is, I'll write it as 0 to 2 greater than or equal to 0 less than 2. 2 to 4. Greater than 4. You want to have more ranges case like 0 to 1, 1 to 2 also you can give for that. I go with 3 ranges. You can, if you want, you can add more. I'll add one more range, that is 1 to 2. This is 0 to 1. Then I go with 2 to 4. Then I go with 4 to 5. I'm going with 5 ranges now. Greater than 5. These 0 to 1, 2 to 4, 4 to 5. Dimension context key. It will apply this at key level. So we got around 944 customers in Eurobor 0 to 1, 1 to 2, 2 to 3, 1. Only 4 customers between 2 to 4. 6,700 customers with 4 to 5. Only 4 customers with greater than 5. Okay, so here I'll go with term deposit percentage also, guys. So let me create some calculations. I'll create a restricted measure. Something like positive customer where it will have all the customers where the predicted term deposit is yes. Okay. How many customers might respond positively? I'll add another measure where I'll go with term deposit percentage. This is like positive customers by overall customer. So here what I do is I'll go combination column and line chart where I'll take customers in line axis. Don't overlap. See here, when your rate is less than 0, means like 0 to 1, 77%, then there is a decrease here between 1 to 2, and again in greater than 5 we have only 4 customers, guys. Okay, you got only 4 customers. In 4 to 5 it's only 0.18, where we have a lot of customers, right? Here you see we got a lot of customers here. Maybe here what I'll do is on Euribor, like edit the calculation. I'll go greater than 4 straight away. There is no point of having 4 to 5. Okay. So these many customers we have, and the here you see the deposit percentage is very low. So we'll get when your Euribor average rate is quite low. Okay. So there is no much deviation. So you see it, we are attracting a lot of customers for the deposit. So this is one factor which follows that. Okay. So this is if your rates were low, if your Euribor interest rates were low, like it's less than 0 to 1, there is a 77% chance on the term deposits. I think if this interest rates are low, okay, so then I think you'll get high interest rates on the deposits, I think. So that might be the reason. If it is high, only 0.1, you see it's decreasing gradually. So this is how you see different factors influencing, right? You'll show it in beautiful reporting format. Okay, let me show how age influences this. Let me also show how age influences. Here age is a measure or dimension. Age is a measure. I need to create a measure dimension again. I need to go create a measure dimension. So let me just check the date of age first. Here I go. Age. I have 17 to 29, 34 to 38. Okay. I'll also create the same way. Create a calculated dimension. Measure based dimension, same story. Age. I write it as age cohort. Means age band. Put age here. 17 to 29. So greater than or equal to 17. Less than 30. 30 to 39. Forty to 59. I created 4 age bands. So okay. So I would like to see the customers in different age bands, guys. Sorry guys, this age band I need to give. First I need to show at what level you would like to aggregate the data. Aggregate at key level. Don't forget this, please. got 41% customers in age band 40 to 59, 37% customers 30 to 59, 13% customers here, 4 customers has null, and only 2.8 customers has greater than 60. Here also guys, I'll go with not customers. In the line axis, I'll go with positive customers. And the term deposits. I just want to insert one more widget on how many customers we have in Euribor. You see guys, we got 9.4 67% customers with Euribor rate greater than 4, 0 to 1 and 1 to. And the positivity, how many customers might respond positively, and their term deposit percentage based on Euribor. Number of customers per age band. And here what I'll do, I'll go simple create a column chat where I'll pick term deposit percentage based on age. Term deposit percentage is quite high in greater than 60. and less than 30 and between 30 to 60. Okay, so you see right how I shown you like how two different factors like customers and age impact. Okay, guys, now I would like to know how other factors impacts this. So what are the other factors impacting? Contact mode, how contact mode impacts, how last contacted month, day of week impacts, campaign calls I can ignore, consumer confidence index impacts, last contacted month impacts. Okay, I would like to see this. Last contacted month, consumer confidence index, contact mode, day of week, how these four factors impact your this one. Okay, so first I would like to go, I'll say insert in new chat. So first for consumer confidence index, I want to create a calculation dimension guys, because consumer confidence index is also measured. Starts from -26. Okay, so here I added dimension. Right, go measure base dimension again. I pick consumer confidence. Okay, I just gave this aggregated key level. This should be applied at key levels. Okay. Yeah, you see how many customers. This is fine. So in this case, instead of going for a dimension, guys, what I'll do is I'll go for type of chart as pie chart. Here in the color dimension, I'll create a dimension input control. So here I go, create a dimension input control. In the dimension input control, what are our factors? Like contact mode, consumer confidence index, contact mode, consumer confidence. What else I need? Last contacted month, day of week, day of week. What is his last contacted month? I think I didn't select this last contacted month. Oh my god, I didn't select this guys in my predicted data set. Okay, what else I have? Each campaign cost days since last contact. I'll take previous campaign outcome also. Mm, okay, I'll take previous campaign outcome. Consumer contract, warranty of week, education of the customer, previous campaign outcome. Instead of yeah, education at least. I select these dimension input controls. I select this. Okay. So how many customers we have in different consumer customers by contact mode, cellular or telephone. I'll insert another chat. I'll go it as combination column and line chart. In the column axis, I would like to see the term deposit, and in the line axis, I would like to see positive customers. Don't overlap. Okay. So you see, if I select contact mode, how many customers we have in both the contact modes, and who might respond positive. What's your term deposit percentage, and who might respond positive. If I go for day of week, number of customers, And the positivity rate is quite high in Tuesdays and Thursdays, right? Monday and Friday it is on lower side. Previous campaign outcome. You see, if it is success, there is a 91% probability it will be successful once again. Education of the customer. We see like this. Yeah, so now the how other factors influencing your campaign data. I just went through multiple using a dimension control. So this gives you a term deposit analysis, how different factors influencing your term deposit where. So in age we get employee, if we have a age of the customer greater than 60, we get more deposit percentage is high. If your above average rate is less than 1, there is high chance of deposits. If contact mode is cellular, there is a high probability. So you see it shows so what are the reasons or what are the factors which influence your term deposits, and here you see which customers might potentially deposit with our bank, right? So this is shown in form of a beautiful dashboard, guys. So that is about my classification predictive scenario. I covered all the 4 steps here, right? We created first data sets on historical and current data. We created a predictive model on using the data from historical data set. We applied the predictive model on current data set to get the predictive outcome, and then we created a beautiful story on top of your predicted data sets to showcase it to the business users, right? So this is about my classification. So maybe I stop here, guys, for today. In the next session, we'll start with regression. We'll start with a new predictive scenario, that is regression. All right, I stop here. Thank you. Have a great day. Thank you so much.